Hello guys and welcome to this new video. Today we are going to talk about the operators in Python. Why do we need to know the operators and what are they used for? Well, operators are used to perform operations on variables and values. In Python we have 7 types. We have the arithmetic, we have the comparison, logical, bitwise, identity, membership, and assignment. In this video, we are going to see each one of them in details. So we start by the arithmetic operators. Arithmetic operators are used with numeric values to perform mathematical operations. We have the plus sign for addition, the minus sign for subtraction, we have star for multiplication, the slash for division, the percentage assignment or the percentage sign for modulus, exponentiation with double star, and floor division. Floor division, it is a division except that it returns the largest possible integer. We are going to add a new cell. For example, we have a equals to 3, b equals to 10, for example. Okay, we add another cell. If we print a plus b, we have 10 plus 3 is equal to 13. If we do subtraction, we have minus 7 because a is less than b. And for example, if we do b minus a, we get 7. Okay, now for multiplication, we can do a times b. We have 30. For the division, we are going to divide b by a, so b divided by a, a is 3.33. For the modulus, we have b modulus a, it gives us 1. For exponentiation, we have, for example, 10 to the power of 3, and we'll have 1000. And for floor division, we have b double slash a, and we have 3. Now we talk about the comparison operators. Comparison operators are used to compare two values. We have 6 of them. We have equal, not equal, greater than, less than, greater or equal, and less or equal. For example, if we choose x equals to 4, y equals to 8. For example, if we write print x equals to y, we have false because 4 is different than 8. We have x not equal to y, we have true. For example, if we write x is greater than y, we have false. X is greater or equal to y, false. But if we do less than, it is true. Less or equal, so we have or. Either one condition is satisfied, so the first one or the second one. We have less than, we have x is less than y, so we have true as an output. For the logical operators, they are used to combine conditional statements. We have 3 of them: and, or, not. And returns true if both statements are true, or returns true if one of the statements is true. Not reverse the result, returns true if the result is false. To try that, for example, we use z equals to 6 and f equals to, for example, 2. Okay, run. For example, print For example, z is greater than 5 and f is less than 5. Okay, print we have true. For example, if we do print z is less than 5 or f less than 5, we have one of them is true, so the answer is going to be true. Okay, we reverse the result. For example, here print not z, we directly copy that, right? Copy paste one, it is false. It reversed the result. It was true, now it is false because we have used the not operator. Now when dealing with binary numbers, we have to use operators called bitwise operators. We have 6 of them. We have the AND, the OR, the XOR, the NOT, shift to the left, and shift to the right. Now, for example, if we have A equals to 7, okay, which is in binary 1, 1, 1, it is equals to 1 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2, which is equals to 1 plus 2 plus 4, which is equals to 7. Okay, now if we do the same thing and we choose B equals to 1, which is equals to 0, 0, 1 in binary, we just replace here. It is 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 times 0 to the power of 2, which means that is equal to 1 plus 0 plus 0, which is equals to 1. Okay, we run that. If we print A and B, we will get 1. So the result is going to be 001 because we have 1 times 1 give us 1, 1 times 0 it give us 0, and 1 times 0 it give us 0. So this is the bitwise AND. We multiply or we do the same thing or the multiplication between each bit by another bit in the other variable. So we have 1 times 1, 1 times 0, and 1 times 0 we get a 1. For example, if we do print A or B, what we have here, we have 7. 7 is 1, 1, 1. Okay, in the OR we have set each bit to 1 if one of two bits is 1. Okay, so we have 1 or 1 give us 1, 1 or 0 give us 1, and 1 or 0 gives us 1. So we choose between 1 and 0, we choose 1. Okay, set bit to 1 if one of two bits is 1. It's the opposite of the AND, where we set each bit to 1 if both bits are 1. We have 1 and 1, we get 1. 1 and 0, we get 0. And we have the same thing for the XOR and for the NOT. For the shift, for example, if you want to shift, for example, we write print A, shift to the left by B, for example, okay, we have 14. which means that we will get 1 1 1 0. Okay, so we shift this to the left. We have 1 1 1. Okay, and we shift to the left by 1. We add 0. Okay, so we shift to the left and we add 0 in here. If we do print A shift to the right by B, we'll get 3, which means that we will get 0 1 1. Okay, so we shift to the right means that we add 0 1 0 here, and we omit the variable that is in here, whether it is a 0 or a 1. Now for the identity operators, we have 2. So they are used to compare the objects with the same memory location. So we have is returns true if both variables are the same object. Is not returns true if both variables are not the same object. For example, okay, if we have two we say two lists. Okay, x equals to, for example, okay, 1 and 2, right? We have y equals to, right, 1 2. Okay, and you put, for example, put a equals to x. Okay, we run that. If we write print x is y, so we have false, even if x and y are the same and have the same content, but they have not the same memory location and they are not the same object. Okay, but if we write print x is a, we have true. Okay, because both variables are the same object. Okay, for the membership operators, they are used to test if a sequence is presented in an object. We have two operators. We have in and not in. So in returns true if a sequence with a specified value is present in the object. Not in returns true if the opposite. Okay, for example, if we have, as we have here, for example, x, so we write 1 in x. Okay, true. If we write 2, okay, 2 not in y, we have false, because we have 2 is present in y. Okay, finally we have the assignment operators. They are used to assign values to variables. Okay, we have the equal sign, plus equal, minus equal, equal, division equal, so divide and assign, modulus and assign, exponentiation and assign, floor div for divide and assign. Okay, for example, if we have x equals to 5, okay, and we run that. If we do x plus equal to 3, print x, we get x equals to 8. So x equals to 8. It means that we have here x equals to x plus 3, which is equals to 5 plus 3, and we have 8. Okay, and it is the same thing for the other applications or the other operators that are used for the assignment. This is all for this video. Thank you for watching and see you in the next one.